Rewrite the following equation in standard form. What is this equation of? A parabola. The highest exponent in it is a 2, correct? Which means it's quadratic, and a quadratic equation forms a U-shaped graph called a parabola. What form is it currently in? No, that's what they want you to rewrite it in. Vertex. Now, the reason it's called vertex form is because this is vertex form, a times x minus h squared plus k. And with a parabola, the vertex is always labeled h comma k. Well, when you look at this, can't you easily identify the vertex's location? 2, 4. That's why it's called vertex form, because you can easily identify the vertex when you just look at it. But they want you to rewrite it in standard form, which is y equals ax squared plus bx plus c. The first thing that you're going to do is you're going to rewrite it. Except for, instead of writing x minus 2 squared, you're going to go ahead and write it out twice, because that's what squared means. Then what do you think I can do next? Distribute. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is another negative 2x. And negative 2 times negative 2 is positive 4. Now I'm going to bring down this 2, and I'm going to bring down this plus 4. But I'm not ready to do anything with them yet, because what can I take care of first? Right, combining the like terms from where we double distributed. And that will become x squared minus 4x plus 4. Okay, now that that's simplified, what do you think we would do next? By what though? Correct. And that will become y equals 2x squared minus 8x plus 4. But what am I going to immediately add? Plus 8. What am I going to immediately add to this plus 8? And it'll become 12. Now it is in standard form. Y equals ax squared plus bx plus c. Does anybody remember when I was teaching you this, how I told you could check it and make sure you've done it right? Graph it. If you go to the calculator and you graph both equations, starting with the one they gave you in vertex form, 2 times x minus 2 squared plus 4. Okay, and then if you graph the one that we just rewrote in standard form, 2x squared minus 8x plus 12. And watch, the first one in vertex form will be graphed in blue. The second one in standard form will be graphed in red. Okay, there's the blue one, the one that was in vertex form. And there's the red one, the one that was in standard form. That means we've done it correctly, because it's the same parabola. We're just changing it from one form to the other. All right, now turn in your packet to page 6. Okay, page 6, here we go. Some quadratic equations in the form ax squared plus bx plus c can be solved easily by factoring. For example, the equation x squared plus 6x minus 16 can be factored into x plus 8 times x minus 2, because 8 times negative 2 is negative 16, and 8 plus a negative 2 is positive 6. But remember, once you factored it to solve it, don't you set each of these factors to 0? And to solve this one for x, wouldn't you subtract the 8 and end up with x equals negative 8? And then to solve this one for x, wouldn't you add this 2 to the other side and end up with x equals positive 2? But you've already seen on some examples that we've done over the last couple of weeks that some of them cannot be factored. Sometimes you cannot find two numbers that multiply to make the c and add to make the b. That does not mean that they cannot be solved. It just means that they cannot be factored. So today I'm going to teach you a different way to solve them. Let's look at example 1. X squared plus 8x minus 10. The very first thing you should do is attempt to factor it. See if there are two numbers that multiply to make a negative 10 and add to make an 8. Okay, so if I'm trying that, the first thing I would say, okay, well 10 times 1. A 10 and a 1 is never going to give me an 8. Then I say, okay, 5 times 2. That will make a 10, but that's never going to give me an 8. So this one cannot be factored. So today I'm going to teach you how to solve it by a process called completing the square. On page 6, the example is already done for you. I'm just about to verbally go through it with you. The first thing that you do is you take the c value, the constant, and you're going to move it to the other side. Now, to move a minus 10 over here, don't you have to add it over? Which is why you now have a positive 10 on the right side. Then after that, you look at the b value. Now remember, this is in standard form. So your a is 1, your b is 8. Your c was negative 10, but now it's been added over. So what is your b? 8. You're going to take the b value of 8, divide it by 2, which will be, and square it, which will be 16. You will then add that 16 in on both sides of the problem. You'll add it over here, and you'll add it over here. Now that you've done that, this side you just simply combine, and that's where the 26 came from. On this side, we now have a trinomial that can be factored because there are two numbers that multiply to 16 and add to 8, and those numbers are 4 and 4. Now, what's special about the complete the square process is that at this point, this will always be a perfect square trinomial, which means the binomials will always be identical every single time. If they're not, that means you've done something wrong. Your binomials will always match. Since they match, doesn't that mean we can just write it once and square it instead of writing it twice? Now, like we were learning a few days ago, to get rid of this 2, wouldn't we now square root both sides? And that would cancel that out, which is why now you just have x plus 4. And on this side, anytime you're solving for x and you take the square root, you put plus or minus on it. Now the last thing to do to get x by itself would be to subtract this 4, correct? Well, isn't plus or minus square root of 26 minus 4 the same thing as negative 4 plus or minus square root of 26? They just wrote it in opposite order, but it's the same thing. And then you just type it in. Negative 4 plus the square root of 26 is this. Negative 4 minus the square root of 26 is this. So that example has been done for you. We're about to try an example on page 7 that has not been done for you. So now turn to page 7. Yeah, okay. So let's look at this example. X squared plus 4x minus 15. The first thing that you should always do is check and see if it can be factored. Are there two numbers that multiply to a negative 15 and add to a 4? No. Okay, there are no numbers that multiply to make negative 15 and add to make 4 because 3 times 5 will make a 15 when you multiply, but there's no way you can add them and get a 4. And then 15 times 1 will multiply to make a 15, but there's no way they will add to be 4. Since this one cannot be factored, we're going to use a new process called complete the square. The first step in that process is what? Correct. You're going to move the constant, which is this minus 15, to the other side. And how is that done? Correct. You're going to add it, cancel it on this side, and then add it on this side. That now gives us x squared plus 4x equals 15. Then step 2 is, what is the b? 4. You're going to take the b value of 4, divide it by 2, which will be, and square it, which will be 4. Don't worry about this stuff. Just do b divided by 2 squared, and you get 4. You're now going to take that 4, and you're going to add it in right here and right here. See how I just basically rewrote this, but now I've added 4 on both sides? Okay, now, I now have a trinomial again. And can this trinomial be factored? Yes. And it's always going to be a perfect square trinomial, which means your factors will be identical. On this side, you just combine them. 15 plus 4 is 19. So what should my factors be that multiply to 4 and add to 4? 2 times 2 is 4. 2 plus 2 is 4. Remember, they have to be identical. Basically, the easiest way to figure out the number that goes in both is to square root that number. The square root of 4 is 2, so it's 2 and 2. Okay, now, since they are identical, and they always will be, otherwise you're doing something wrong, you're going to write it as a binomial squared. Some of you need to pay attention. I'm looking across the room and you're not paying attention. Okay, so see how the only thing I've done different now is instead of writing it twice, I read it once and squared it. Now remember, our whole goal is to find out what x equals because we're trying to solve for x. So the first thing we need to do is eliminate the squared. And how do we do that? Square root. And then those cancel out, leaving x plus 2 equals, the square root of 19 is going to be a decimal, so I'm just going to leave it as the square root of 19. But anytime you square root something when solving, plus or minus has to go on the square root. Okay, now what is the remaining step to get x by itself? Subtract the 2. So that'll be plus or minus the square root of 19 minus 2. Or you may see some people write it as negative 2 first, then plus or minus the square root of 19. That does not matter. I just want you to recognize that it can be written either way. It's the same thing. Okay, now to find your two answers, and we know there should be 2 because we're dealing with a quadratic equation, the highest exponent is 2, is you type in the square root of 19 minus 2. So go ahead and type that in, square root of 19 minus 2, rounded to the tenths. And what do you get? 2.4, because isn't it like 2.35? So 2.4 if we're rounding to the tenths. And then you type in negative square root of 19 minus 2. And you get negative 6.4. That's why the plus or minus sign is so important, because it gives you 2 different answers. And we need 2 different answers because think about it. A parabola is a U shape, so isn't it going to cross the x-axis in 2 different places? So that's why we have 2 different answers. Okay, now, you don't have to write this down, I just want you to look. Everybody look at the board. Remember, our original trinomial at the top was x squared plus 4x minus 15. And we weren't able to think of 2 numbers that multiplied to negative 15 and added to 4 because they're not whole numbers. They're decimals. Okay, but focus, if 2.4 is the final solution, doesn't that mean in factored form it would have been an x minus 2.4, the opposite sign? And this in factored form would have been an x plus 6.4? What is negative 2.4 plus 6.4? No. 4. Isn't negative 2.4 plus 6.4 4? And now in your calculator, do negative 2.4 times 6.4. It's negative 15 point something, right? The reason it's not exactly negative 15 is because didn't we round these answers? Had you not rounded them and you wrote every single number, it would have been exactly negative 15. So do you see how this works? Do you see why you had to do this process? Because nobody would ever have been able to sit here and rack their brain to find those numbers. Okay, so now let's try the next one. Go to the next page, number 1. Okay, what is the very first thing we should do? Correct. The first thing you should always do is check to see if it can be factored. Are there two numbers that multiply to 75 and add to 20? No. 5 and 5 plus what is 20? Right. And 5 times 15 is 75. Well, I'm just showing y'all that you don't have to use complete the square if it can be factored. You only have to use complete the square if it can't be factored. There's no reason to waste your time doing that lengthy process on something that can be factored. So now, we've only factored though. We have not solved. Remember to solve? That's when you set each of them equal to 0 and then just solve for x. So on this one, how will we solve for x? Correct. Subtract 5 on both sides. And so one of your solutions is negative 5. And then for this one, how do we solve for x? And so your second solution is negative 15. Now remember, what's special about those two solutions is those are your x-intercepts. If you put this on the graph, that's where it will cross the x-axis. And those are the two numbers that when plugged in for the x will actually make it equal 0. All right, number 2. What do we do first? Yes? The axis of symmetry is the line that cuts down through the middle of the parabola. No, these are the x-intercepts where the u cuts through the x-axis. Well, let me graph it to show you a visual. Y equals x squared plus 20x plus 75. Okay, I see the parabola. This is obviously the right side of the parabola, judging by the slant. And isn't it crossing at negative 5? Why can we not see the other x-intercept? It's at negative 15, way over here somewhere. We would have to change the window to see it go through negative 15. Okay, number 2. First, you check to see if it can be factored. Are there two numbers that multiply to make negative 24 and add to make negative 10? Right, it's a negative 12 and a positive 2. 6 and 4 wouldn't have worked because there would have been no way for the signs to work out to make a negative 10. Now, since it can be factored, you just quickly set each of the factors equal to 0 and solve, and then you'll have your two solutions, your two x-intercepts. This one, won't you just add the 12 over and get x equals 12? And then for this one, won't you just subtract the 2 over and get x equals negative 2? Okay, so it's easy when they can be factored. All right, number 3. Can this one be factored? Are there two numbers that multiply to make a negative 14 and add to make a negative 10? No. So for this one, we're going to have to use that new process called complete the square. And what is the first step? Correct. We're going to add this 14 to the other side. So x squared minus 10x now equals positive 14. Then what do we do? Right, you take the b value, divide it by 2, and square it. Well, what is the b value for this trinomial? Divided by 2? Negative 5, and negative 5 squared is 25. You're now going to take that 25 and you're going to add it in on both sides of the equation. Okay, on the right side, you just simply combine like terms and those become a 39. On the left side, you now can attempt to factor a new trinomial. Are there two numbers that multiply to make 25 and add to make negative 10? Well, what's the square root of 25? So 5 times 5 is 25. Negative 5 plus negative 5 is negative 10. Since there are two of them and they're identical, how can we now write them? Right? But remember, our goal is to get x by itself, so now what should we do? Square root it. Those cancel each other out, leaving x plus 5 equals plus or minus the square root of 39. And now the last step to get x by itself is what? Subtract this 5 to the other side. And so now to get your two answers for x, which are going to be approximations because it's going to be decimals that you round, you just type in positive square root of 39 minus 5 and negative square root of 39 minus 5. You put a plus or minus on it. Yeah, because we're trying to get x by itself, so to get this 5 away from it, we had to minus it to the other side. I'm going to have x minus 5, x minus 5, x minus 5. Oh, no, I made a mistake. Yeah, this should be x minus 5 equals plus or minus square root of 39. And then, yes, you add the 5. Okay, so now square root of 39 plus 5 equals what? 0.2. Okay, and then negative square root of 39 plus 5 is, right, yes. You're learning it because not all trinomials can be factored. Some trinomials, there are no two numbers that exist that multiply and add. They do exist, but they're decimal numbers, so you can't just simply think about them. Some people will. Some people will go on to be architects and engineers. Can this be factored? Are there two numbers that multiply to make a negative 20 and add to make a negative 8? I think there is. Let's see, it's definitely not 5 and 4. Yes, a negative 10 and a positive 2. Then at that point, you set them equal to 0. And you add the 10 over, and so one of your solutions is a v plus or a v equals positive 10, and the other solution after you subtract the 2 over will be v equals negative 2. Yeah, but it's harder than that sounds. All right, number 5. Yes. Okay, are there two numbers that multiply to make negative 27 and add to make 6? Yes, there are. 9 and negative 3. They multiply to be a negative 27, and when you add them, you get a 6. And so b plus 9 gets set equal to 0, and to solve it, you subtract the 9 over, making your final answer a negative 9. And then you set b minus 3 equal to 0, but when you solve it for b, you add the 3 over, making it positive 3. What? Okay. Are there two numbers that multiply to negative 36 and add to negative 20? No. It seems like there might be. Like earlier I started trying 18 and 2, but in order to make a negative 20 with an 18 and 2, both of them would need to be negative, and then when you multiply them, two negatives won't make a negative. So this is one that requires complete the square. So what do we do first? Correct. Add the 36 to the other side. So now we have p squared minus 20p equals 36. Now what do we do? Right, you take your b value, divide it by 2, and square it. What is the b value? Divided by 2, negative 10 squared, 100. So you now add 100 to both sides. Okay, now, on the right side is simple. 36 plus 100 is just 136. On the left side, it should be simple for you by now because we've been factoring a long time. You just look for two numbers that multiply to 100 and add to negative 20. And they have to be the same. And the easiest way to know them is just take the square root of that number. What's the square root of 100? 10 and 10. But for them to add to a negative, they both need to be negative. Okay, now you write it you write it once, even though there's two of them, and square it. And now what do you do? Square root, and then square root this side. Those cancel each other out, leaving p minus 10 equals plus or minus square root of 136. And now the last step is what? Add the 10 to the other side. And now to get your two answers, which are going to be approximate because you're going to round them, you just do the square root of 136 plus 10 and negative square root of 136 plus 10. So go ahead and type those in. Square root of 136 plus 10 is what? 21.7. And then you do negative square root of 136 plus 10, and you get negative 1.7. Okay, next question, number 7. Can this one be factored? I'm thinking, yeah, an 8 and 2, an x minus 8, and an x plus 2. So if those are the factors, what are the final solutions? Right. All right, number 8. Okay, can this one be factored? Okay, what numbers multiply to negative 80 and add to 16? What? $20 and negative 4. Okay, k plus 20, k minus 4, because 20 minus 4 is 16, 20 times negative 4 is negative 80. And so if those are the factors, what are the actual solutions? Correct. All right, number 9. You ready? Can it be factored? Okay. What numbers multiply to negative 11 and add to negative 10? 10 times 1 is not 11. 11 times 1. Negative 11 and positive 1. And so the final solutions will be what and what? Negative 1. Okay, number 10. Are there two numbers that multiply to negative 50 and add to 20? No, there is not. So what do we do first? Add the 50 to the other side. And so now you have r squared plus 20r. I'm going to go ahead and write in the blank to fill in, just to save, writing. Now how do I fill in that blank? What do I put on both sides? B divided by 2 squared is what will fill in that blank, correct? What is your B? Divided by 2 squared. Right, so 100 is what gets filled in on both sides. The right side simply becomes 150, and the left side is now a trinomial that I can factor. And what's the easiest way to figure out the numbers? The square root of 100 is 10. 10 times 10 is 100. 10 plus 10 is 20. That's why this is called a perfect square trinomial, because they match. Now r plus 10 is written twice, so I'm just going to write it once and square it. And now what will I do to now solve for r and get it by itself? So r plus 10 equals plus or minus the square root of 150. And then what do I do? Minus 10, minus 10. And so r equals the square root of 150 minus 10, which is right, 2.2. And then your second solution, because we know there's always 2 with a quadratic equation, is negative square root of 150 minus 10, which is negative 22.2. Your homework is page 9, the odds. I'm pretty sure 2 of those odds are factor, and the other 3 I think are complete the square. I may be wrong because I haven't done them, but I know at least 2 of them can be factored, so at most you'll be doing complete the square 3 times.